Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AZIM bin AHMAD FOZI. My maintain number is AA191548. And now, I will show how to solve the problem statement 1 for our group project, which is the ladder diagram for PLC application. Let's read the problem statement 1 first. Okay, so for problem statement 1, a single acting cylinder will extend when push button is pressed. Lamp will on when the cylinder has fully extended, detected by limit switch. After 4 seconds, the piston will retract to its initial position and the lamp will switch off. Okay, so this is the answer for problem statement 1, which is the pneumatic diagram and the ladder diagram. Let me describe and tell the whole flow on this pneumatic and the ladder diagram. To begin the process, we need to press the start button above. So first, push the PB and it will energize the R1, which is relay coil 1. The open contact R1 in round 2 and round 4 will be closed. Then, the valve solenoid 1Y will energize. The 3/2-way solenoid valve will change the position. As we can see, the air pressure will flow through port 2 into the single acting cylinder and it will push the piston to reach 1V1. The max switch 1B1 at the ladder diagram will close, energized relay with switch on delay R2 and turning on the light. The switch on delay is set for 4 seconds as a given problem statement. After 4 seconds, brake contact R2 will open and break the whole circuit and turn off the light. And the piston will go back to the initial position. Okay, this is the tools that I have used in this problem statement 1. The first one is single acting cylinder. Second one, 3/2-way valve. Third one, push button Mac ladder diagram. Air service unit. Valve solenoid. Brake switch. Mac switch. Indicator light. Relay and switch and relay with switch on delay. Okay, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad ASRAFF yang JAMILUS. So, saya akan menunjukkan solution untuk problem statement 2. So, untuk soalan ni diminta a conveyor system works as follows. A start button is used to turn on a conveyor belt A that brings bottle to the filling station. Sensor 1 placed at the center of the conveyor A will stop the conveyor belt A upon detecting the bottle. Here a valve will open for 2 seconds for filling the liquid into the bottle. After that, the conveyor will move again until the bottle is scanned by sensor 2 at the end of the conveyor. Conveyor A will stop again and the solenoid will energize for 3 seconds for the piston to push the bottle onto the conveyor belt B. The process is repeated for another bottle until the stop switch is pressed. So, ini ialah untuk kita punya solution. So, ini bila kita boleh tekan play untuk teruskan kita punya simulation. So, kita tekan play. Dan kat sini kita akan mengalir air lah. Lepas tu kita akan tekan start untuk mulakan kita punya pergerakan conveyor. Okay, seperti yang kita tengok. Oh. Okay, seperti yang kita tengok kat sini, dia akan berhenti selama 2 saat untuk dia isi air lah dalam botol tu. So, tekan lagi, teruskan 3 saat. 3 saat ni untuk dia energizkan solenoid untuk tolak botol ke belt B. So, ini dia akan teruskan, dia akan ulang-ulang sampai dia tekan button stop. So, setiap interval ialah 2 saat dan 3 saat. So, stop. Dia akan selesaikan. Dan kalau dia belum selesai, dia akan selesaikan botol terakhir bila kita tekan stop tu.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Haikal Hashim bin ABDUL WALIT. My number matrix is AA111375. I'm from section 2 and group B and group 2. So I will continue for problem statement 3. Problem statement 3 state that figure Q3 shows a PLC control cylinder system with 3 single acting cylinders, cylinder A, B, and C. Momentary start button PB, momentary emergency button EB, and 3 limit switch sensors A, B, and C. So the figure 3 Q3 cylinder system show that the cylinder A as a Y1, cylinder B as Y2, cylinder C as Y3, and the sensor A is as S1, sensor B as S2, and sensor C as S3, and we have the start button PB and the emergency button EB. The process sequence as per follows. Initially, Y1, Y2, and Y3 are not energized. The initial position of cylinder A and C is retracted, while cylinder B is extended. Start button is pressed. The cylinder B retracts. Sensor B detects full retraction for cylinder B. After 3 seconds, cylinder A extends. Sensor A detects maximum extension for cylinder A. After 4 seconds, cylinder C extends. All the system reset or off when the sensor detect maximum extension for cylinder C. The system also will reset and off when the emergency button is pressed at any time during the operation. So we will recreate the problem statement 3 at the simulation of fluid sim pneumatic. So this is the pneumatic system and leader diagram at the fluid sim pneumatic software. For the simulation, we will recreate the problem statement 3 at the fluid sim pneumatic. So this is the pneumatic system and this is the ladder diagram. This is the component that we use and this is the setting that we set. So for the pneumatic system, so for the cylinder A and C will detected a position, and the cylinder B will be at the extended position. So for the component, cylinder A, B, C is the single acting cylinder. For the valve is 3/2-way valve with push button. And for the sensor A, B, C is the distant roll. As supply, we are using a compressed air supply. Power supply electrical connection 24 volt for the ladder diagram, and ground electrical connection 0 volt for the ladder diagram. For the ladder diagram, we are using a push button as the start button. S3, S2, and S1 is the sensor contact. And for the Y1, Y2, and Y3 is the valve solenoid. And we are using R1 coil and R1 contact. And then we are using T1 coil and T1 contact, and T2 coil and T2 contact. And lastly, we are using the emergency button EB. So the component that we are set is the T1 and T2. For the T1, we are set for 3 seconds, like it's the for at the statement problem 3, and the T2 we are set for 4 seconds. So when we push the push button, the R1 will energize. Coil R1 will energize, and the R1 contact will close. When the R1 in close position, Y2 valve will energize and change the position. When the Y2 change the position, the cylinder B will retract, and when the S2 sensor sense the limit of cylinder B, it will S2 contact will in close position and energize the T1 coil. When the T1 coil is energized, it will count. It will set the time for 3 seconds, and after the 3 seconds, the contact T1 it will be in close position and change the Y energize, and it will energize the Y1 valve and change the position. When the Y1 valve change the position, the cylinder A will be extend, and when it reach the limit, it will trigger the S1 sensor, and S1 sensor will be in close position and will trigger and energize the T2 coil timer on delay, and T2 contact will be in close position and energize and trigger the Y3 valve, and then Y3 valve will change position, and then when the cylinder 3 extend and reach the limit, the system will restart or off. So what happened when we push the emergency button? So we push the push button first, and then we push the emergency button. So it will reset the system or off the system. Again, we push the emergency button, it will reset and off the system. So that's all from me. We will continue with the problem statement 4.
Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD USAMAH bin NAZAR, and my matric number AA191939, and I'm from section number 4. Problem statement number 4. Figure Q4 shows the PLC CPM2A used to start and stop the motors of a segment conveyor belt. The object is passed from one conveyor to the other. Proximity sensor located next to each conveyor segment, sensor 1, 2, and 3, are used to locate the position of the object. Assume there is only one object per cycle. The process sequence as per follows. When start button is pressed, motor 3 turn on, and motor 3 is always on unless the stop button is pressed. Sensor 3 detect the object, motor 2 turn on. Sensor 2 detect the object, motor 1 turn on. After 2 seconds, motor 2 turns off. Sensor 1 detects the object. After 2 seconds, motor 1 turn off. Based on this problem statement, 3 proximity sensors should be included that is needed to use for each conveyor segment. This is a ladder diagram and electropneumatic circuit that shows how the motors and sensors operate when they detect objects. When the start button is pressed, the 24 volt of voltage supply applied in this electropneumatic circuit. The sensor 3 function as proximity sensor. It will detect an object and trigger of motor to run. Timer 1 will trigger also and only allow motor 2 to run for 2 seconds. And sensor 2 will detect an object that allow motor 1 to run. Timer 2 also will only allow motor 1 to run for 2 seconds. Last round in the ladder diagram, sensor 1 function for repeating the process as other object bypass. Each sensor will not turn off until the stop push button are pressed.